In the next three examples, we're not going to be asked to find the probability. We're going to be given the probability, or the area, and asked to find the value x. To do this, we must first find the z-score. So let's look at our procedure. The procedure for finding a value x given the probability, or the area. So again, we'll begin by sketching and labeling and shading the curve. Then we'll use the inverse norm function, and what goes in the parentheses there is the area to the left of whatever this value x is, to find the associated z-score rounded to 2 decimal places. So we'll be able to tell what this area is after we've drawn the picture and labeled it. Then we'll have the z-score, but we're trying to find the x. So now we will use the z-score formula to calculate x, because we will know z, we will know mu, and we will know sigma. The only thing we won't know is x. And then we'll interpret our results. So we'll return to that same example that we were doing with the weights of men, and see a problem that involves not finding probability, but finding the value x. Okay, so again, the weights of men are normally distributed with a mean of 172 and a standard deviation of 29 pounds. So again, I'm going to jot that down and get a different color here. So we have a mean of 172 and a standard deviation of 29. It's a good idea to pull this information out of the paragraph or out of the sentences, so it pops and you won't make a mistake looking up and grabbing the wrong number. Okay, so part A says, what weight, see it's asking us for a weight, an x. What weight separates the lightest 99.5% of men from the heaviest 0.5%? And we'll round this weight to 1 decimal place. Okay, so as we said, we're going to sketch, label, and shade the curve. And our mean is still 172 on our x number line. And let's get our z number line going, our corresponding z-scores. The corresponding z-score for the mean is 0. And so there's some value x that separates the lightest 99.5% of men from the heaviest 0.5. So in other words, there's some weight that on the right side, the heaviest part, is only 0.5% of the area. And then the other 99.5% are lighter than that. So we're way over here. Some weight right in there. There's some x that we're interested in that separates these two. So, oops, don't need that. Okay, so what we do need is to shade. Now what I want to shade is always the area to the left, okay, because that's what I'm going to use with the inverse norm function. So I'm going to shade area to the left of my value of interest, x. I don't know what x is, that's what I'm trying to find. Okay, so now that I've shaded that, and look at this, I can identify that this area here is my 0.995, or 99.5%, and that, of course, this area over here, this last little bit here, is the 0.005, or just a 0.5%. And the question is, what is this weight right there? Okay, so I've sketched and labeled and shaded the curve. Now that I know what the area to the left of my value x is, then I know I can use the inverse norm function on the calculator. Area to the left, 0.995. I don't have an option to put in either one of the areas because the calculator won't know what I'm looking for. If I put in 0.005, that would be way down here. So I have to always put the area to the left. So what this is going to give me is a z-score. It's going to give me the z. Once I have the z, I can calculate the x. So I'm looking for a z-score. This will give me a z-score. Okay, so let's pull up our calculator. All right, so on our distributions, second distributions, inverse norm is the third function. Tab down. Enter. All I put in here is area to the left of my value of interest. So that's 0.995. Now, let's think ahead. What do we think this area value is going to be? Or what we know what our area is. What do we think this x value, is going to be? Significantly bigger than 172. So our z should be pretty far out here, right? Because that's significantly bigger. We're way down here. So let's see what we get for a z-score. Okay, more than 2 standard deviations, more than 2.5 standard deviations. This is a z-score, so I'll round it to 2 decimal places. 2.575 would round to 2.58. That is the z-score associated with my x value. I know that it's 2.58 standard deviations above the mean. I know that. Now I need to know what it is. To do that, we use our z-score calculation, right? Where z equals x minus mu over sigma. But this time I'm not calculating z. I know z. There it is. 2.58. What I don't know is x. I know mu, that's 172. I know sigma, that was 29. So it's a little bit of algebra. So how do I clear this denominator out? To clear the equation of fractions, we multiply both sides of the equation by the least common denominator, and in this case we just have 1. So I'm going to multiply both sides of the equation by 29. Okay, so on the right hand side my 29's cancel and I'm left with x minus 172, and on the left hand side I get 74.82. Okay, now I want x by itself. Get another color here. So I'm going to add 172 to both sides. And finally get, that just won't go away, finally get my x equals, adding these two together I get 246.82. Now remember, this is my x. It is weight. These are pounds. I'm trying to find the weight that's right there that separates 0.995 area from 0.005. And this is what I got. And it said round to 1 decimal place. So I'm going to say that this is 246.8. That's my x. Okay, my interpretation then, fit it in over here, is that the weight that separates the lightest, I can just use the words that are given in the problem, the weight that separates the lightest 99.5% from the heaviest 0.5%. is 246.8 pounds. In other words, 0.5% or half a percent of men weigh more than 248.6 pounds, or 99.5% of men weigh less than 246.8 pounds. All of those things are true based on this calculation. Okay, well, let's look at another problem similar to that. Let's go back to our percentiles. Find P15, which is the weight that separates the bottom 15% from the top 85%. Remember, P15, that means 50% of the values are lower than this value, whatever we're looking for. 15% of the values are lower than this one. Okay, so here's our 172 on our X scale. And we want P15, where 15% of the values are lower. So at 172, 50% of the values are lower. So I know I'm down here somewhere. Okay, where 15% of the values are lower. I want that X. I'd like to know what weight that is. Okay, I'm going to shade the area to the left of my value of interest because that's what I'm going to put in my inverse norm function. Okay, so for z-scores, on my z-scale, of course, the mean is 0, and I'll have to calculate this one. Okay. So, now that we have that, what are we thinking about what this weight will be? Well, it's going to be a pretty good bit lower than 172, right? We should have that in mind as we go through the problem. It's a good idea to sort of estimate in your mind so that if you get a number that doesn't fit, then you'll go back and check your work. Okay, again, let me label these areas. You notice I'm doing this from the top instead of putting it down on the number line because that 0.15 represents this area, not a place on the number line, but all of that area. So that's why I'm labeling from the top with arrows like that. It's not correct to put the probabilities or areas below the number line. So obviously the unshaded part is that 0.85 or 85%, the unshaded part. Okay, let's find this z-score for right here by using the area and our inverse norm function. Area to the left, always, always. This will give me the z-score that's associated with that area to the left. Okay. Go to the distributions. Third one down is inverse norm. Type in area to the left, 0.15. And this is our z-score. We knew it would be negative because it's to the left of the mean, negative 1.0364, and I'm supposed to round to 2 decimal places, negative 1.04. This is my z-score, so let's put it here, negative 1.04, just a bit below 1 standard deviation below the mean, just a little bit further than that. Okay, now I want to calculate x. If I know that z equals x minus mu over sigma, which I do, I know z, I know mu, I know sigma, I'll solve for x. Negative 1.04, z equals x minus mu over sigma. Again, to clear the equation of fractions, we multiply both sides of the equation by the common denominator. There's only one denominator here, so that's what we multiply by. Okay, on the right hand side the 29's cancel, and on the left hand side we get negative 30.16. Now we add 172 to both sides to get x by itself. And we get an x of 141.84. And we were told to round to 1 decimal place. So our x is 141.8. Okay, and we expected it to be a bit lower than 172. This weight right here that separates the bottom 15% from the top 85%. So let's write our interpretation. P15, or the 15th percentile, the weight that separates the bottom 15% from the top 85%. That's a P, believe it or not. Is 141.8 pounds. In other words, 15% of adult males weigh less than 141.8 pounds. Or 85% of adult males weigh more than 141.8 pounds. Okay, one last example. Now we want to find Q3. Remember the quartiles? Q3, the weight separating the top 25% from the others. And let's just quickly review. Remember how the quartiles divide up a data set into 4 parts. 25% of the data to Q1, another 25% to the median, another 25% to Q3. So if we're finding Q3, we're finding the weight that separates the top 25%, right, from the others, this bottom 75%, right? Okay, so let's sketch, label, and shade our curve. $172, and that z-score is 0, and we know we're above the mean, the top 25%, so we know it's somewhere over here. But now I want to shade area to the left. I'm looking for this X value right there. I wonder what that is. Well, the area to the left, that every time I go for blue, that's going to happen. Okay, the area to the left of the Z of interest is this area. Significantly more than halfway, because this is our 75%, right? Or 0.75. And here's our top 25%, or 0.25. Okay, so I need this z-score. Once I get that, I can calculate this X. To get the z-score, we use inverse norm. And I put in the parentheses the area to the left, and my nice diagram keeps me from making a mistake and grabbing the wrong area, because I've shaded the area I need. Okay, let's find out what our z-score is. Distributions, third one down, area to the left, 0.75. And our z-score is 0.644, and so we would round that to 0.67, sorry, 44. Round that to 0.67. Z-score is to 2 decimal places, 0.67. Okay. And here. All right. Well, we know that Z equals X minus mu over sigma. So the Z, 0.67, equals X, what we're looking for, minus 172 over 29. Multiply both sides by the denominator. Cancels here. We have 29 times 0.67, 19.43. Can't use blue. Okay. Add 172. And we get X is equal to 191.43. And again, round to 1 decimal place. So X is 191.4. So the third quartile, Q3, is 191.4 pounds. So in other words, 75% of males weigh less than 191.4 pounds and 25% of males weigh more than 191.4 pounds.